Find the fourth roots of cosine 120 degrees plus I sine 120. Express the answers in trigonometric form. So, when we want to know the roots, we have a theorem, the nth roots theorem of a complex number, and it kind of came from the idea of looking at De Moivre's theorem and the product rule. And so I'm going to go ahead and write down what the theorem says. It says if you want a certain root to get the roots, it's going to look like this, and then it's going to be cosine of, and we've got our argument theta plus, and then it's going to be 2 pi k, or 360 in our case since we're dealing with degrees, and then plus I times the sine of that same angle, so theta plus k times 360 degrees over n. So there is our theorem. Now we'll go ahead and apply it to our problem. So r is the modulus, and our modulus in this case, when we look at our complex number, is a 1. I'm going to go ahead and write it in. N is the root, so in this case a fourth, and then it's going to be cosine of, theta is our angle, 120, plus, I'm going to call it root sub 0. It's the first root, but it's when you let k be 0. So if we put 0 in here, this is gone. And then this would be, so this would be 0 over n, which was 4, plus I times the sine, and this, I'm just going to write same angle because it's going to be the same angle, and once you compute it for the first one, it's going to give you the same thing. So the first one is going to be, I'm using r for modulus and r for root here, but I'm subscripting this one so we'll know. So 1 to the 1/4 power is still 1. This is going to be, it said to leave it in trigonometric form, so 120 divided by 4 is going to be 30, plus I sine same angle of 30. Okay, then to get the next one, the only thing that changes is the k value here in the formula, and now k is going to be 1. So I'm just going to go up here in our formula and change it since I don't have a lot of room to leave to do things differently. So let's, and I'll go ahead and just change it to a different color so you can see where I'm modifying it. Now if I let k be 1, this will have a 360 right here. So I'm going to have 360 plus 120, which is going to be 480, but then I need to divide that by 480, and that will go in there, so it looks like 120 times. So this is going to be cosine of 120 degrees plus I times the sine of that same angle, 120 degrees. Now to get the next one, I'm going to do the same kind of thing, but here I have the 120, and that's going to be added to, I'm going to let k be 2, so when I put 2 in here, it's going to have 120 plus 2 times 360. 840, but I still have divided by 4. So 4 will go into 8 2 times, 4 will go into 4 1 time, so it looks like it's going to be 210. And then sine of the same angle. And then to get the last one, I'm going to do the same thing, but I'm going to put a 3 in for k. So let's go over here and work that. It's going to be 120 plus 3 times the 360 degrees. So this is going to be 3, this is going to be 8, carry the 1, 1080 plus 120 divided by 4. So that looks like that's going to be, what, 1200 divided by 4. So 4 will go into 12 3 times and put our 2 zeros on there. I sine 300. So our 4 roots in trigonometric form look like that. If we needed them to be standard form, we could go ahead and work those trig functions and we would get the roots in standard form.